morning, class. So let's have compound proposition. So this compound proposition is a proposition. It's a proposition, and that is composed of two or more simple proposition connected by logical connectives. So these logical connectives, you have and, you have or, you have if, then, and then not, if, and only if, and you also have exclusive or. So first, let's have this connective and this is conjunction. So this conjunction of the proposition P and Q is the compound proposition P and Q. We have Q, and in symbol or symbolically, this P and Q, where this symbol is the symbol for and. Okay, so do not forget that this symbol is for and then I think we have also mentioned this in our set theory in discussing elements in the operations of sets. So the property of this conjunction is if P is true and Q is true, so you have P is Q and Q is true, then P and Q is true. Otherwise, P and Q is false. So the meaning is the conjunction of two propositions is true only if the proposition is true. So we need that the P is true and the Q is true to have a result of true as the truth value. Otherwise, it's false. So you have here P and then your Q, and then P and Q. So your P is true. When your P is true and your Q is true, P and Q is true. And P is true and your Q is false. So obviously this is false, because we need all or both P and Q are true to have a truth value of true. Now if your P is false and your Q is true, therefore you will have false. And your P is false and your Q is false, so you will have false as the truth value. So this is conjunction. Again, you will only have a truth value of true if and only if, or if your P is true and your Q is true. Otherwise, everything is false. Questions? Okay, do you have any questions so far? So where did I get this? Maybe you are asking about how I get this true, true, false, false, true, false, true, false. So propositions, we know that propositions in our previous topic is the truth value is either true or false, right? So the same with flipping a coin. If you have your first coin, you will have either its head or tail, right? And then what if you have another coin? So this is the first coin and second coin. The same with proposition, true or false, you will have head and tail. Now the question is, what is the possible outcome? What are the possible outcome in flipping or tossing a coin? So we will list all the possible outcomes. So to do this, we can use a tree diagram. So you have head, tail as your first, and then you match that in your second. You have head, tail, and head, tail. And then you will have the result head, 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 tail, tail, head, and tail, tail. So that's how we get it. So these are all the possible outcome if you toss a coin, head, tail. So you have head, 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 tail, tail, head, tail, tail. Now the same with this one. You have two proposition. You have P and Q. And then you have the outcome true or false. Because P as a proposition, it should be true or false, but not both. The same with your Q as a proposition. So P and Q are just variables. It can be replaced in any statement. So you have true or false. So we will use the tree diagrams. You have true, false, and then we will match that with true, false. Let me erase. And then this one with true, false. So you will have a result of true, 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 false, false, true, and false, false. So basically these four are the outcomes or possible outcomes or possible answer. What if your first proposition is true and your second proposition is true, and then your first proposition is true and your second proposition is false, and then your first proposition is false and your second proposition is true, and lastly, what if your first proposition is false and your second proposition is false? So this is how we arrive with this table. So you have true, 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 false, false, true, false, false. Okay, so again, so we have this, how we come up with those true and false, and then you have the truth table for conditional. You have the truth table for conjunction, and then you have this definition and the property of conjunction, and of course the compound proposition. So that is compound proposition and conjunction.